Welcome all. I want to discuss some questions in this class. This is the first question. The rate of interest is given 4% per annum, convertible monthly. Welcome all. Yes, anyone? Tanvi, you answer.
Yes, sir.
Yeah, what is given here and what you need to find?
I12 is equal to 0.04% is given, and we need to find D.
Okay, you need to find D. What is given?
I12.
I12, convertible monthly. Okay, so that's great. I12 is given 4%. And you need to find D here. To find D. Okay, so if I12 is 4%, that is given, and you need to find D, how you would like to find?
Just find I, then equate it with 1 minus D is equal to 1 by 1 plus I.
Yeah. Okay, let me write from the left hand side 1 minus D, that is equal to 1 by 1 plus I, right? Okay.
Yes, sir.
That is 1 plus I power minus 1, and that is equal to 1 plus I12 divided by 12 power minus 1, that is 1 plus I12 upon 12 power minus 12. When you put the value of I12 here, directly you will get D. Are you compatible with this, Ritik?
Yes, sir.
We are in the very initial stage here. The annuities and the interest rates are fundamental to all the application chapters. Okay, we'll apply everywhere. These are the fundamentals here. So CM1 is not all about interest rates. Even 1% is interest rates or maybe less than that. But then you have to understand and you have to use properly so that you can save a lot of time. So just put 4% here. 1 plus 0.04 upon 12 power minus 12. So you can connect directly D to I12. Okay, these are the ones we need: I, D, IP, DP. When we talk about interest rate, these are the 5 things. We'll use these 4 mostly. Delta is called force of interest. That is where we need differentiation integration a little bit, but that's not used in all chapters. But these are used in all chapters. Okay, though easy, but you must feel comfortable. Now you put 4% here and then use a scientific calculator and then try to find the value. Okay, and you will get the answer. So if you find it, you will get 3.91%. You can take it. Not
Yes,
now.
sir.
Yeah, not now. If you are doing with me, that's fine. Otherwise, you don't need to do now. This is a practice class for you. Question 2. Calculate the total present value as at 1 June 2008 of payments of 100 on 1 January 2009 and 200 on 1 May 2009. So you must be able to draw a number line. If you take this as 0 in the number line here, 2 payments are here, 100 and 200, June to January, July, August, September, October, November, December, January, 7 months, right? So you have to write 7 divided by 12 here, and then after that May, from January, February, March, April, May, so 4 divided by 12. 12% per annum convertible quarterly. That means I4 is given here. This is 12%. And you need to find the present value here. You find the present value of this one here. 2 payments are here. And then find the present value of this one. And you have to add. The question is, calculate the total present value as at 1 June 2008. Okay, 0, 1, 2, 3, they are not given. So you have to make a number line this way. If you have any doubt, you can ask me whenever you have doubt. So 100, here I can write 7 divided by 12, 4 divided by 12. From I4, am I correct? This is 7 divided by 12, June to January. Yeah, 7 by 12. So either you make it monthly or directly also you can find this value V712, 7 divided by 12. You can write this 200, then V11 by 12. See, from here I should write 11 by 12 here. Actually it's not this, because I'm counting from here. Okay, so you have to find these two and you have to add these two, that's all. So what is V here? V is 1 upon 1 plus I. From I4 you have to find I, and you can use this equation. Any other way you can answer? Are you comfortable with this?
Yeah.
Okay. Anyone suggest any other way? Check this one. Okay, you're fine. You can make it monthly also if you want. You can count how many months are here. Suppose I'll count this way: 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. If you do this way, you have to find monthly interest rate. Okay, that way also you can do. But this is better. Why not do directly? Because I4 is given. What is given, that is important. I'll give you 1 or 2 more questions once these are over. I have some questions I want to discuss with you. So I6 now, you have to write this as superscript, but yeah, this is typed. So we got this. I is given 7%. You have to find I6. Direct formula is there. Then D, from I to D. You need to find D6 from I, that's all. I is given, you need to find D6.
So 1 plus I is equal to 1 by 1 minus D.
Okay.
And 1 minus D is equal to 1 minus D6 by 6 whole power.
Yeah. This you are saying?
Yes, sir. This is what I'm telling.
Okay, that's fine. You put I here, 7%. You solve it, and then you can find, not a problem. Okay. So we don't want in between. We don't need D here. So you need not find D. Directly you can equate. You put I here, use calculator, you can find D. That way you will be able to find D2 also. This one. And this one is direct. 1 plus I4 by 4 is equal to 1 plus I. That formula you can use. So this is quite simple. How many parts we have? 2 parts here and 2 parts here. Let's do part 1. In all of these cases, you need to find the effective annual rate of interest I. So in A, what is given? Nominal rate of interest of 11% per annum convertible half yearly. So what is given? Nominal rate of 11% per annum convertible half yearly. So what is given here?
I2 is given.
Okay. I2, right? That is 0.11. How about this, the second one? Nominal rate of interest of 12% per annum convertible monthly. I12 is given. 12%. And you have to find I. So direct formula. You have to find I, direct formula. Okay. How about this? Calculate the rate of interest convertible monthly corresponding to an effective rate of interest 12% per annum. 14.2% per annum. So in part 2, you have to find I12. Okay, you need to find I12 here. In both of these, I is given here, and convertible three times a year. So what is given here in part B?
I 1 by 3.
Right. Here, if you want to use the formula, you can use this one. You put I2 11% here, and you will get I answer here. And in this case also same formula, 1 plus I12 divided by 12 power 12, that should be equal to 1 plus I. So given this one here in the left hand side, you have to get answer here. However, in this case, we have to write 1 plus I12 divided by 12 power 12, that is equal to 1 plus I. You put I value here and get answer here, I12. Okay. Let me do part 2B. If you see, I 1 by 3 is given here. So I'll write I 1 by 3 divided by 1 by 3 power 1 by 3. Okay, you have to solve this. If you solve this, you will get I. Again, from I, you can find I12. So if you don't want to find twice, you can write. So put this value 11% here, you will get answer here. This is 11.3025%. This is 12 point. The second one 12.6825%. You can check it, okay? And this one here and this one here. This will be 13.3518%. This one 10.8519%. Now, I got some of the questions from you. When it comes to matching the answer, remember, there will be differences. But if you write 1275, if you get this one, answer is given 1278, that's fine. But you should not get something like this 1.1472 or 1.13. In some cases, you might get this also, but there must be a lot of calculations. So if you are getting this way, then there must be some problem. You have to check once again. And remember, decimal point 6 you have to take. Minimum I'm saying. 1, 2, 3, 4, 5, 6, 7. Okay, you can take up to 6 decimal places. And in the last step, if you want, you can keep 3 or 2 digits, whatever is required. But before that, I mean, in the first or second line, during the problem when you are solving, you have to take many decimal points. Okay, many, when I say at least 6. A woman who has won a prize is offered a lump sum 100,000 to invest now, or 55,000 to invest at the end of this year, and another 55,000 to invest at the end of the following year. If all investments are assumed to earn 7% per annum, which should she choose if she intends to withdraw the money after 4 years? There are two parts here. We'll do part 1, then part 2. Okay. So she won prize. Now she's offered two things. One is 100,000. This is one option. Other option is 50,000, 55,000 to invest at the end of this year. So either you get one time, lump sum means once, okay? Once you get this money, or the other alternative is 55,000 to invest at the end of this year. So they will give end of this year. This is start, okay? Now means normally 0. End of this year 55,000, that means this one 55,000, okay? And another 55,000 to invest at the end of the following year. So which one is better? They're saying. Which one is better? After winning the lottery, she is given two options, okay? She needs money only after 4 years. That means you need to find the accumulated value of this one after 4 years and these two payments after 4 years.
Yes, sir.
Yeah. So you have to see which one is greater. See, make it simple. Immediately you get 100,000. Immediately she will get 100,000. She can receive this money, okay? And she can invest for 4 years. After 4 years, this money will grow to, in thousands I'm writing, I'm not written 3 zeros. 100, what is the interest rate? 7%. 1.07 power 4. That's all. You use a calculator and you find this value. And in the second case, they are saying we'll not give you anything now. We'll give you 55,000 at the end of this year. Means at the start of second year or end of this year. We always write one, remember? And after another year, 55,000. So this is better or this is better. If you want to take the money after 4 years only. So invest this whenever you receive this one, because you don't need now. You need only after 4 years. So you invest for 3 years, okay? From 1 to 4. So this will grow to 55,000. 1 plus I power 3, I is 7%. And after another year, after 2 years, they will give this amount. So this amount will grow to 55,000 1 plus I power 2. You add this 2. You find this value, find this value. If this is more, then you accept this one. If the accumulated value, we say accumulated value of these two are more, okay, you accumulate separately, then you can add these two, then you choose this option. For the women, there are two chances. It will depend.
So, but here the first case, I mean, the second case, first 55,000, it will go for 2 years, yeah? Or 3 years?
3, right? 1 to 4, 3 years, right?
Oh, okay, fine.
Yeah, 1. See, this is what I said initially. When you see this, certain things we use in CM1, you will be able to know the language is specific to only this paper. What they've written, invest at the end of this year or start of next. That is the same. That is 1 always. And another 55,000 to invest at the end of the following year. So end of this year is 2. Then we are finding money after 4 years. After 4 means you have to count 1, 2, 3. I have not written 3, 4. That way this is better.
Yeah.
But in the second case, they are saying you want to withdraw after 2 years. That means in this case we will find after 2 years, and in this case that's all, because whatever money you get, that money is with you. You will not invest this money, the second money, because you want to find the value here. So this will not grow. Even if you keep in the bank, you withdraw after 1 minute that way. Or maybe it will come to your bank, immediately you will go and you have to withdraw. But first time whatever they've given you, that will be there with the bank for 1 year. That will grow with this interest, and this is immediate. So you have to see this is better or this is better.
So again, first one is better.
Okay, the first one, right?
Yeah.
Okay, fine. If you have any doubt, you can ask me. I think we have 2 more questions. Here you have to calculate the effective annual rate of interest for a transaction in which 200 is invested for 18 months to give 350. Part 2, a transaction in which 100 is invested for 24 months and another 100 for 12 months, starting 12 months after the first investment to give 350. Okay, you have to find I. Let me write part 1 here. So 18 months. Now Ritik, I would like to hear from you. 0, 18 divided by 12, 18 months, 200 here. Okay, and 18 months 350. This is the first one. And the second one, 100 invested for 24 months, 2 years I can write. $100 invested for 24 months and another 100 for 12 months, starting 12 months after the first investment. That means here 1 I can write, okay, or 12 by 12 you can write. Another 100 here, okay, yeah, another 100 here for 12 months, okay, starting 12 months after the first investment. That means after these 12 months, okay, here to give 350. I mean, I need not write 12 by 12 all that. I can write this is 1, this is 2. It's very simple, okay. That means you invest now, you deposit. If you are not investing in stock market, you deposit 100 in your bank, another 100 after 1 year, and when you go and withdraw, they will give you 350. So twice you invested or deposited your money, and once you received your money 350. Here you need to find the interest rate. That is the question. Effective annual rate of interest. You have to solve and find I here. In this case, you invested 200 and you got 350 after 1.5 years. You have to find the effective rate of interest. Yeah, tell me the equations and then I'll write the answer. Yes, Ritik. 200 grows to 350 in 1.5 year. That is 18 months. Okay. So
Yes, sir.
yeah, what is the effective rate of interest I? 18 months means how many years?
1.5, sir.
Yeah, you can write 1.5, right?
Yes.
Because this could be a fraction also. Directly you can write this one. Solve this and find I. That's all. You have to use a calculator. 350 divided by 200 you need to find. Then raise to the power 1 upon 1.5. Then subtract 1. Okay. If you have any problem, you can go through the fundamental videos time and again. There won't be any problem. Then very high interest rate, 45.22%. Even I thought, because 200 you deposited, you got 350 per 100. If you find, roughly it's 150 extra you are getting, 75. Okay, so it's quite more, but 1.5 year, it's not 2 year. Sorry, it's not 1 year, so little bit it will decrease. So that's how 45%. And here, what is the equation you need to write? Here two amounts. Okay, you deposited this amount, you deposited this amount, you got this amount. What is the equation you need to write to find I?
So 100 into 1 plus I to the power 2
Correct.
plus 100 into 1 plus I to the power 1.
Okay, fine. That's fine. 350. You need to solve this one. Yeah.
Yes.
So you need to solve this one. For that, yeah, you can go on mute now. You can write this way. Then you find 1 plus I. From 1 plus I, you can find I. Okay. So you can use the formula. Minus 350 is equal to 0. X is minus B plus or minus square root of B square minus 400, 350. Use the calculator. 2a. So 1 plus I, you will get, from 1 plus I you have to get I. Okay. So here 1 plus I will be equal to 1.4365. You take 2 roots, you will get. Okay, whatever you want to accept, you do it, and you will get this one. You can check. So I will be 0.4365. Around 43% you are getting. Okay, 43.65%. Calculate the accumulated value after 6 months of an investment of 100 at time 0 at the following rates of interest, force of interest. So this I didn't teach you. Okay, I'll take class for this separately. We'll do this too now. And those who have studied, it's fine. Okay. If you are considering appearing in September, the more you do, the better it is. Because as I said you already, those who want to continue for the next session will check after a month or 3 weeks. If you are able to appear, that's fine. Otherwise, we have other students also. We'll have a batch. We'll do with all problems. We'll have a lot of classes. But if you are thinking of appearing in September, I joined 5 students. Okay. Some will go there, some will stay here. That I'm not deciding now. For the next 1 month, you do whatever you can. Okay. That will be useful. If you master annuity, life will be very easier. And annuity depends on interest rates. That's all. I don't remember exactly from where annuity chapter I've started. You can leave the force of interest. Those who have not done now, that is not required. Not use much. Little bit integration is required. You have to master I, IP, DP. And you see annuity is quite interesting. Here in this chapter, we consider only one payment. In annuity, we consider many payments. Okay. Like 100 here, 100 here, 100 here, 100 here. What will be the value here? Something like this. So we have to find the future value of all this. But anyway, that will come later. I'll give you a class also. 1 or 2, then we'll discuss. Okay. Problems. Now in this, you have to find after 6 months value. Here, what is given? A rate of interest of 5% per annum convertible monthly. So convertible monthly i12 is given. Whatever it is, i12 is given. From i12, you have to find this value. So directly, if you want to write, I will consider 1 month. I can write this. 6 periods. I have 6 periods here. 1, 2, 3, 4, 5, 6. Each period is 1 month. So I've written period interest rate here. If you write this way, directly you will get the answer. There are many ways. I'm not saying you have to do this way. You can find I. You can write 100 into 1 plus I power half 6 by 12. You can write that also. Now, an effective rate of interest of 5% per annum in part 2. So when I is given, instead of I12, you can directly use 6 by 12. That is half 100 1 plus I power half or 6 by 12, whatever this one. This is half here. So you can write half, that's all. You will get the answer. It's easy. This is over now. I'll discuss 2 to 3 problems with you. Suppose I need to invest here some amount, 250. I want to get it after 4.5 years. Okay. So what will be the accumulated value here? I want to know the actuarial symbol. I want to know the expression after 4.5 years.
So, but at what interest?
Okay, what interest? Suppose I4 is given. Let me write it. This is given. Quarter interest rate is 5%.
So 264.
264. Okay, you tell me the expression.
Okay, like what I did.
No, yeah, well, no, the expression here. Okay.
Okay, so 250 into
yes.
1 plus I4, which is 5%, 5 by 100
Okay.
by 4, the whole raised to. Oh, okay, wait, I made a mistake. I think the
Okay.
whole raised to 9 by 2. I wrote. That's
Okay.
wrong.
Okay. So 4.5 years. Quarters. How many quarters are there in 1 year? Suppose this is 1 year. This is 2 year. This is 3 year. This is 4 years. 4.5. So because you have taken quarter, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Okay. 18, right?
Yes, sir.
Okay. Now, Amit, tell me where I need to put 5%. Sorry, not Amit. Ritik.
Instead of I4, sir. Instead of I4, sir.
Okay, instead of I4. Tanvi?
Yes, sir.
Yeah. Tell me where I need to put 5%.
I4.
I4. Okay. Joel, where I need to put 5%.
So I think I4 by 4 should be 5% because
Yeah.
it's not given convertible. That's why.
Yes. Convertible is not given. This is whole I4 by 4. This is quarter interest rate formula. Okay. So I'll write here 0.05. Quarter interest rate is different from convertible quarterly. Remember, convertible quarterly. Convertible quarterly means I4. Once it's converted, okay, then you get quarter interest rate. That is the difference. Difference between this and this. If I said quarter interest rate, this is a quarter, 5%. That means roughly 1 year interest rate is 20%. Tell me, Tanvi, if quarter interest rate is 5%, yearly interest rate should be more than 20% or less than 20%?
More.
Yearly interest rate is more than 20%, right?
Yes, sir.
Okay. So if quarter interest rate is 5%, how can you find yearly interest rate? Can you find yearly interest rate from here?
Yes, sir.
Yeah, how?
So I plus I4 by 4 to the whole raised to 4 is equal to.
Yeah, this is the formula we use.
Yes, sir. Just
we put 5% here. So let's take what is yearly interest rate here. I4 by 4 is 5%. Okay, you solve it. 1.05 power 4 minus 1.
yes, sir.
What is that?
So 21.5%.
Yeah, 21.5%. Okay. We'll go back to our original question now. This was the question. I've given quarter interest rate is 5%. So the value answer is this one. Okay. It's not that I have to use this expression always. What is given, I have to check. If I change it to, suppose, given the rate of interest per annum convertible monthly, how you will do the problem? Yes, Tanvi, tell me. The rate of interest per annum convertible monthly is 8%. Then what will be this expression?
So I12 will be 0.08.
Yeah, that's fine.
So it will be 250 into.
So how many months are here? Okay, monthly. So 1 year, 2 year, 3 year, 4 year, 4.5 year. So you count number of months here. 4 into 12, 48, 48 plus 6, right? 54.
Yes, sir.
250, 1 plus I12 by 12 power 54. Then you have to write 250, 1 plus here I12 is given 8%, convertible. 0.08 divided by 12 power 54. This will be the answer.
Yes, sir.
Okay. Now, Tanvi, question for you.
Yes, sir.
Suppose I will say you should not erase this one. Okay, using this expression only you do. Can you do using this expression only?
Which expression, sir?
The first expression I wrote right here. I don't want to do this way separately. I want to get answer from this expression only. Is it possible?
Yes, sir, it is possible.
How? How?
Sir, we can equate 114 to 112 and get an equation.
You just find I4, right? See what is given.
Yes, sir.
What is given here? What is
0.
given? No. This is I12 is given, right? I12 is given 0.8. From I12 you find I4 and put here. What I want to say actually is, see, if I say this one, expressions are infinite. Expressions are not finite. So to do easily, okay, suppose you want to find the accumulated value. For this only I can write 1 plus I power 3. For this I can write 1 plus I2 divided by 2 power 6. So 3, when I calculate in years, there are 3. If I calculate in half years, there are 6. If I calculate in months, 36. All expressions are correct. Suppose I12 is given, I2 is given. For I2 also I can use all the expressions. From I2 I can find I and put here, I will get this one. From I2 I can find I12, I can use this expression. So how you calculate, all are equivalent, okay? Mathematically all are the same. Whatever way you do, you will get the same answer. However, in the question, if I2 is given, then why not use second one? If I is given, why not use first one? If I12 is given or I12 by 12 is given, why not use this one? Directly you will get the answer. So don't get confused, okay? So now you need to know I, IP by P, IP, DP by P, DP. These are the three things you have to know properly, okay? So you revise all the videos and do it properly. I will take a small test also before going to annuities. Now, I have another question for you. My question is, suppose you want to get your money after 1 second, okay? And you invest 50,000. What is the amount you will get after 1 second if you deposit? So though we never do this practically, But mathematically, if you use the formula, how much you should get after 1 second? I is given, suppose 50% per annum. Can you tell me what is the second interest rate? Instead of
365 into 24 into 60 into 60.
Okay, 1 plus I 365 24
into
60.
24 into 60 into 60.
Okay. Okay. So after 1 second, right? If I make it after one month, same I is given. So I have to change it to I12 by 12, right? I'm not writing any power because the period I have taken 1. The period is 1. Okay, here this is 1 month. This is not 1 second. Okay. Last time I wrote 1 second. If nothing is written, this will be considered year. 1 by 2, 12 year. This is 1 month. So 1 month I have written 1 plus 1 by 12. Suppose I write 2 months here. Or maybe I'll write 6 months. Then what will be the expression? Half year, right? 6 months is half year. I have two options. I write I2 by 2. This is one option. The second option is this is one only, one period. That's why I'm not writing anything. However, I can make it 6 periods. 1, 2, 3, 4, 5, 6. So if I make 6 periods, then this 50,000 will grow to 50,000 1 plus, but here I will not I2 by 2. Here I will write I12 by 12 because these are monthly. And how many months are there? 6. So if you want to write power 1 only, for 1 second, I made 1 second 1 period. Okay, now 6 months I have. So monthly if I take, I can write this way. If I take 1 period only, I will write power 1. If I make 6 periods, I will write power 6. That way I can do. Half year I can make 2 quarters also. I can do this way, 1 quarter, or I will write 1 by 4, 2 quarter, 2 by 4. So you write the same expression this way. 2 quarter interest rate we know, power 2. 2 means 2 power. 6 means 6 power. 1 means 1 power. This much what you are supposed to know in interest rate. That's all. Nothing more. And we have simple interest also. Simple interest is very easy. Suppose 1 year interest rate is 10%. Half year interest rate will be I2 by 2, not I2 by 2. Directly you can write 10% by 2, 5%. Quarter interest rate I by 4. That is 2.5%. It's simple. Simple interest rate is very simple. Simple discounting is also there, D. Okay. We have some problems also. If you have covered those, you must be knowing. Now I have a question. Suppose this is suppose 3.5 years, and you need to find the accumulated value of 300 after 3.5 years. And here D2 is given. How can you find this value? See, one way is, you can say probably the best way, you find I from D2 and you can using I, that's all. This is always there with you. 3.5. This expression is always there. If you have any problem, you find I and put here, that's all. This is over. This is one expression. I want directly from you. Directly how can you find? So you have so many options. From D12 you find D. Using D you should be able to find. Remember 1 plus I is again, instead of putting directly, instead of finding I and putting here, you know, you already said this is 1 minus 1 divided by 1 minus D, 1 by 1 minus D power minus 3 by 12, it will be minus 1. So from D2 you find D and put here, or directly you write an expression like this. Power 2 means it will be minus 7. Directly you put D2 here. Okay.
Yes, sir.
So you can make your life easier slowly when you use in a problem. You must be comfortable using interest rates. I'm saying if you are not feeling 100% comfortable, you go to the videos, you solve a set of problems. If you have anything to ask, any concern you have, any doubt, you can ask me before